Okay, we are briefly going to go through some of the slides from some of the first slides here. So, the first thing we want to talk about is what exactly is nutrition. It's the process involving the intake and utilization of food substances. That's quite simple. From the time you put it into your mouth to the time what's left over comes out the other end, and what you use it all for when it's digested. So, what do these food substances provide? Primarily, they're going to provide energy for running, jumping, swimming, blinking, thinking, digesting, all of your energy requiring processes. They're going to promote your growth and development, right? And they're going to regulate your metabolism. So, really quickly, we can divide our nutrients up into two kinds, macro and micro. Basically, macro means big and micro means small. So macro nutrients are things like fats, carbohydrates, proteins, and water. We measure those things in grams or more. Micronutrients are things we ingest in small quantities. Examples of those are vitamins, minerals, and phytochemicals. So it's really easy. Just remember that macro is large and micro is small. Okay. So another way we can divide them up is essential and non-essential nutrients. So essential nutrients are things that you can't make. Your body can't make it. You need to eat it. And so some examples of things that are essential are fiber, some fatty acids, some amino acids, lots of vitamins, and as well as minerals. Okay, non-essential are things that you can make as long as your body's given the proper building blocks. So those are non-essential amino acids, fatty acids, and glucose are just a few examples of those things. So there are many non-essential and essential nutrients in the foods that we eat. Okay, so what do these foods provide us with? They provide us with energy. So we usually express energy in calories or kilocalories. So food energy cannot be made directly into mechanical energy. You eat a hamburger, it doesn't just go straight to your muscles and allow you to walk around. There's a substance called adenosine triphosphate, or ATP for short. Just remember ATP. And all food energy is made into ATP. ATP is the universal energy carrier for all living things, all plants, animals, insects, everything, right? ATP, remember that. So, what nutrients provide energy and can be made into ATP? Basically, we got three things. We've got carbohydrate, protein, and fat. So carbohydrate provides 4 calories per gram, protein 4 calories per gram. Fat is over twice as dense per gram per unit of weight, right? And that's obviously very important. Things with fat are more calorie dense. So all these things can be turned into ATP, the universal energy carrier. Okay, if it doesn't contain one of those things, it does not contain energy. Caffeine doesn't give you energy. Drugs, legal or illegal, do not give you energy. Only fat, carbohydrate, and protein give you energy. Okay, all of these things are turned into ATP. Okay, so now we're going to skip forward to factors that affect food choices, right? So I'd like you to read about this a little bit in your book, but just be conscious of the fact that we don't obviously eat food just for energy and just for growth and just for regulation of our metabolism. It can be cultural things, social. We're influenced by advertising, how much time we have, our habits, our emotions, how available food is to us, whether it's because of money or whether it's because of time. Some people, their habits are grossly influenced by how much money they have to spend on food, while other people, they don't really have to worry about the money that they spend on food. Okay, so then let's talk more about non-energy providing nutrients. So vitamins and minerals are two of our big things, and we'll have specific days where we talk about this. So vitamins are primarily responsible for making enzymes, and cell membranes, and parts of bigger, more complex molecules. Minerals, some of the things they're used for are to make teeth and bones, as well as enzymes and other metabolic processes. So most people, when they think of minerals, the first thing they would think of would be our largest mineral storage, which is the calcium in our bones. And right now, this is all you really need to know about vitamins and minerals. In our later modules, we'll get to specifically to vitamins and minerals individually. So another thing that we ingest in large quantities is water, right? Our bodies have a lot of water in them. So our fat-free mass, right? Our mass that is our part of our body that is not fat is 73% water, right? A little more than 2/3. And fat mass is close to 0% water. So, you might hear people say like, oh, our body is 80% water or 90% water. You'll hear those things, but that's really not true. Again, your non-fat mass is 73% water, and your fat mass is pretty much 0% water. So most people are about half to 2/3 water. If someone who's very fat will have less water as a percentage, and somebody who's very lean will have more water as a percentage. Okay. So what does water do? It's involved in many physiological processes. It carries substances throughout the body, right, via our blood. It's used for lubrication, maintains our temperature, cushions our organs. Water has a lot of uses, and we'll have a specific section just on water as well. So let's talk about how we get these nutrients, these fats, these carbohydrates, these proteins, water, vitamins, minerals. So the dietary guidelines for Americans describe a healthy diet as one that emphasizes fruits, veggies, whole grains, fat-free, and low-fat milk or milk products, as well as lean meats, poultry, fish, beans, eggs, nuts, things like that. We also want to be low in saturated fats, trans fats, cholesterol, salt, and sodium. You can use those terms interchangeably, as well as added sugar. Okay, so I'm going to, after this presentation, I'm going to go through your text a little bit and highlight what I would really like you to take away from your text. But definitely, understand this PowerPoint slide and read up on it. Okay, supplements. So really quick in this intro, I want to talk about supplements and how supplements are not really necessary for most or all people. They may be appropriate in some circumstances, such as calcium for young women or iron for women who are pregnant, issues like that. And we'll talk more about those when we get to, we have specific sections on supplements. But understand that really most people don't need supplements, and they're not really required for optimum health. Okay, so your book has a really important section on where to find good nutrition information. So where do we find good nutrition information? Well, the best place to find it is journal articles, right? Journal articles are articles that are written by professionals for professionals. And the thing about these articles is they're peer reviewed. So that means that experts write the article and other experts look at it, right? That's pretty, and that's a very robust system. That means that only the best stuff gets through. So, as far as where we do find good information, these articles are great, but they're very difficult to understand. So while they are number one, they're definitely the highest ranked place to get good information, they can be difficult to understand. If you don't understand it, you may get the wrong takeaway message. So always keep that in mind. The next best way to find things would be articles written by an expert, such as a registered dietitian or a physician, as well as textbooks written by a registered dietitian or a physician. Below that, you would have other articles, magazine articles and things like that, written by a physician or a registered dietitian, that type of expert. Below that, you have things written by journalists. While many journalists are good, they're not necessarily writing about their area of expertise, so that is the downside of things by a journalist. Below that, and what I would call completely unreliable, are articles that are not written by an expert or an experienced journalist or have no author whatsoever. So sometimes you'll find articles on eHow and things like that that do not have any they do not have an author. You can't trust it. It's like finding a piece of paper on the ground. Even Wikipedia would belong in that area. Now, that doesn't mean that on Wikipedia you can't find good information, but a good Wikipedia article will go back to original sources. It'll go back to journal articles. It'll go back to more reliable sources so that you can look those up. Okay. One more thing about finding good nutrition information is when you're looking for nutrition information, and especially when you're on the web, you've got to keep in mind, is somebody trying to sell you something? If somebody is trying to sell you something, either directly on their website or with the article, you have to view it with a lot of skepticism. Just because they're trying to sell you something doesn't mean that they're wrong, but it may mean that their motivations are more towards trying to sell you something and less towards giving you good or proper information. So you've got an expert that's trying to sell you something, view that with skepticism. If you've got a non-expert that's trying to sell you something, I would tend to take that with a grain of salt. So really read this and understand this portion of your book. It's very important. Okay, so I want to talk a little bit about the scientific method. The scientific method is basically the process that we use to find to figure out information and do research studies. So what we do with the scientific method, it's got several steps. The first one is to ask a question. So the question might be, what is the effect of carbohydrate replacement on 10K running performance? Right. Then we develop a hypothesis. So our hypothesis might be that it will help 10K running performance or that it will not, whichever. And then we conduct an experiment that isolates the variable. So we want to be very careful to isolate, make sure what we're measuring, what we think we're measuring. We want to make sure that we're not measuring how hot the day is or that we're measuring how fit the runner is, that we're actually measuring the effect of our variable, which in this case would be carbohydrate consumption, right? So then hopefully we'll do our study, we'll answer the question. We have to share the information, okay? And that's all part of the scientific method. And we share that information through the journal articles. So that's pretty much all I really need you to know about that. So, and a final important part about the scientific method is that one study does not make an absolute fact. For an issue to be commonly accepted as fact among professionals, results have to be repeated and supported by researchers in multiple studies. They have to. So if I find something in my lab, somebody else has to find something in their lab as well, or else you have to view it again with a little bit of skepticism. This is very, very important. That one study does not make something an absolute fact. Okay, so that's the end of this slideshow, and we'll post another one soon. Thanks.